Ever wondered why maths matters outside of school? Spoiler, it kinda shows up everywhere. In this video we're going to break down some key mathematical concepts clearly and simply. Whether you're studying, relearning, or just curious, you're in the right place. Please remember to like and subscribe, I really appreciate the support. Let's get into it.
Okay, let's look at the final example of our sketching subset questions. There is so many different twists and turns you can put on these questions, and I've kind of tried to combine a lot of them into this final example. Now, hopefully from the earlier examples, we remember that whenever I'm sketching a subset, I let z equal to x plus yi to help us mirror the Cartesian plane and make the sketches look and feel a bit more familiar. Now, I want to do the same thing here, but if I notice I've got two parts, I've got two different subsets, and I'm combining both of them. I have the subset of 1 is less than or equal to the modulus of z, which is less than 3, and I have the union of the subset of z, and I have pi on 4 is less than or equal to the argument of z, which is less than pi on 3. Now, we have to remember that our argument of z here, this is referring specifically to the angle my complex number makes with my Argand diagram. So I have two parts. I have an actual equation, and I also have kind of an angle section that I'm going to be considering as well. Now, if I just consider the first part of my question and I substitute in x plus yi, that is going to give me 1 is less than or equal to x plus yi is less than 3. And again, I want to take the modulus of that x plus yi part. If I find the modulus of x plus yi, that gives me 1 is less than or equal to the square root of x squared plus y squared, which is less than 3. If I square everything in my inequality and I scroll down just a little bit here, that is going to give me 1 is less than or equal to x squared plus y squared, which is less than 3. And I should put a little squared symbol on my 3. And I might just put one on my 1 as well. That way we can see that there. So this is a bit of a weird sketch question. And if you haven't worked much with inequalities, this might not necessarily be something we're familiar with seeing. If I draw this on an Argand diagram here next to my question, what I essentially have is two circles. I have the equation where x squared plus y squared is equal to 1. In other words, I have a circle with a center of 0, 0 and a radius of 1 that looks something like this. And I also have x squared plus y squared is less than 3 squared. So again, I have a center of 0, 0 and I have a radius of 3. So I have two circles. My second circle I'm going to do in red, and that is going to look something like that. And I'll just remove the sort of shaded part there. And I might just try to center that a little bit more as well. And if I zoom out a bit, we can clearly see there, that is the subset of 1 squared is less than or equal to x squared plus y squared, which is less than 3 squared. If I just wanted to shade that region, I'm shading the region between 1 and 3. Well, that is going to look something like this. I'm going to be shading in all of this part here in the middle. Now, I did make a slight error. This isn't actually equal to 3, so I should put some little broken lines in here to show this isn't exactly equal. Instead, it's just less than this particular value. So make this part here a broken line. The broken line represents just less than instead of less than or equal to. So that's my first subset. But again, I'm going to be combining this subset with pi on 4 is less than or equal to the argument of z, which is less than pi on 3, or the second part to my equation. So for this second part, there's not necessarily a bunch of working out I really need to do. For part 2, this part over here, I have pi on 4 is less than or equal to the argument of z, which is less than pi on 3. Now, I don't actually need to sub in x plus yi into my argument formula here, because all I'm really doing is identifying where pi on 4 is and where pi on 3 is. Well, I know pi on 4 is about 45 degrees. That's going to be in quadrant 1. So it's going to be a line that looks something like that there. Now, if I consider pi on 3, well, pi on 3 is 60 degrees. I'm going to do pi on 3 in pink. And that is going to be a line that looks something like this. Okay, so there's my two lines. This part here, I'm going to label it. This part here is my pi on 3, and my purple line is pi on 4. Now, again, it's just less than, so I should also represent that with some broken lines. So I'll just erase a little chunk there and a little chunk there, and I'll do a little patch there in the center so we can see that this is just less than, and I'll kind of fix up my highlighting here. That's all nice and highlighted again. Okay, that is my angle between pi on 4 and pi on 3, and my angle is in between those two. Okay, so I want to shade both the region between 1 and 3 for my two circles, which I've already done. I've already shaded that part. And I also want to shade this region in between my two angles here as well. And you can see there's a little bit of an overlap there between the two. And I'll make my highlighter a little bit smaller. Let's get right into the bottom part there. Okay, perfect. So that's all that question is. It looks a little bit complex, but because it's my union, it is both when z is between 1 and 3, and when z's between pi on 4 and pi on 3. If I change my questions slightly just to show a few sort of deviations we can have, if instead of being the union, it was instead the intersection, so I have my sort of upside down U, well, if it was just the intersection, I would erase all of my highlighting out here, and I'll just highlight the section where both of these two parts overlap. Well, both of these two parts, if I just try to tidy up my highlighter, both of these two parts, let's get in here too, overlap here in the middle, and I'll put that part there in blue. So if it was the union instead, I would just highlight this little part here, which has become green because, you know, blue and yellow make green, but I would highlight just this region here in the center instead. Even though we're combining a lot of ideas and a lot of skills, it's still the same process. Substitute in x plus yi into my equation. Whenever I'm finding the argument or the angle, I can simply just sketch on my Cartesian plane, or sorry, I should say my Argand diagram, where those angles are. And again, these could exist anywhere between 0 and 2 pi. So just keep that in mind. Both of these were in quadrant 1. It doesn't have to be in quadrant 1 though.